Hello and welcome everyone. Very happy that we're all together again. In this tutorial, we will continue talking about the different types of the overcurrent relays. So fasten your belt and let's get started. The aim of this tutorial is to continue learning the different types of the overcurrent relays that we started on the previous tutorials. So let's go ahead. First of all, if we need to know what are the different types of the inverse relays, we said in the previous tutorial that the inverse relays has three main types. And here the first one of them is the very inverse relay. And the very inverse means that its relation between the current and the time has a larger slope, which means when the current increases, the time delay will decrease very much as a result of that larger slope. And the first property of that type of the very inverse relay is that it's used when the power feeding is going through the different directions. So if we have the power going through the forward direction and the reverse direction at the same time, we will use that type of relays. And the second property of the very inverse relay is that when the current decreases from 7 times till 4 times, its delay time is doubled. So it has a specific slope that allows the delay time to be doubled when the full current decreases from 7 times till 4 times. Alright. Now the second type of the inverse relays is the extremely inverse relays, and at that type we have an extreme relation between the current and the time delay, which means the delay time decreases extremely when the full current increases. And we use the type of the relays and the applications at which we need a very fast action of the relay, or in other words, we need a very small delay time that the relay will take an action after which, so we can make a coordination between the type of relays and the protection fuses. As the fuses has a small time to break the circuit, so this type of relays also consumes a smaller time, so we can make an arrangement of the delay time between it and the fuse. And also the second application at which we use the extremely inverse relays is that we use it if we need to protect the distribution feeders, like those feeders, at them we are feeding some constant loads. So in case of the feeders feeding constant loads, we are using those type of relays. And also we use the type of relays in case at which we need to protect the power transformers, like that case also, and also if we need to protect the cables. So this is the use of the extremely inverse relays. Now the third type of relays under the inverse category is the inverse definite minimum time, and that type of relays is a combination of two types. The first one is the inverse relay and the second one is the definite time relay. And this means this type of the relay works inversely for a specific region, or it has an inverse relation between the current and the time for a specific region, and it works with a constant or a definite time at any fault current for another region. And here this is the relation between the delay time and the current for that type of relays. As you see at the first region, the fault current is inversely proportional with the time, and at the second region, when the fault current increases, the delay time becomes a constant one, or it's a definite time at any passing current through the circuit. And we can see the relation between the current and the time for the three types of the relays: the very inverse, the extremely inverse, and the inverse definite minimum time relay in that graph. As you see, this is the inverse definite time curve, and this is the very inverse type current time relation, and this is the extremely inverse graph. And we can note easily that the extremely inverse type is the most steep one, or it has the largest slope, which means the time decreases extremely when the fault current increases. And we can compare between the three types if we suppose that the current value to be that one, so it cuts the three curves and three different points. Here for the inverse definite current time, as it has the lowest slope, so it has the largest time to be 4 seconds, while for the very inverse type it has an intermediate slope, so its delay time is intermediate to be 2 seconds, and for the extremely inverse type it has the most largest slope, so it has the lowest delay time to be 0.4 seconds only. Very good. But for all of those three types, we can add an additional module, which is called the directional module. And the use of that directional module is to specify the direction at which the relay will trip the circuit. And this is the directional protection, which we illustrated before, which is to has a specific direction for each relay to trip the circuit if the current is increasing through it, while it will not trip the circuit if the current increases through the other direction. For example, this relay detects the fault on its right direction only or out of its path. And this relay detects the faults on the left direction only or out of its path also. And the same idea for the other relays, as each of them has a specific direction to work on. More than great. So let's about this tutorial at which we continue talking about the different types of the overcurrent relays. Hope that's clear right now. Thank you for watching and see you next tutorials.